All right, so we're going to be in lesson 8-6 and lesson 8-7. And I'm teaching these two lessons simultaneously because the process is not going to change regardless of what the trinomial looks like. Oh, it may be two, because we're going to have to write down steps and we're going to do lots of different practice problems, okay? So we're just going to call this factoring trinomials. Now, in the past, we used to break it down. Well, what if this number was positive and this number was negative? What if this number was negative and this number was negative? What if there's a 1 in front of your squared term? What if there was something other than 1 in front of your squared term? The reality is the process I'm going to teach you works on all of it, okay? It even works on binomials. It even works on perfect square trinomials. So you don't actually need to learn any other technique. Other techniques just speed up the process in very specific problems, and we'll talk about that down the line. So today's date is the 19th, right? 18th. 19th. Yeah, 19th. Okay, so we're going to do one problem together, and then, actually, we'll do two problems, and then we'll write down steps, okay, because I want to give you one of each kind. All right, so I'm going to give you this problem. We'll start with this one. X squared minus 8x plus 12. Now, in order to factor trinomials, you need to learn how to play a game. Are you guys into playing games? Yeah, I think so, yeah. So this game that we're going to play is called the product sum game. Okay, and this is how the product sum game works. I'm going to multiply the coefficients of the first and third terms. Now, please note, you're always checking for GCMF, and I knew there wasn't going to be one because my quadratic term, the term out in front, had no coefficient. So I knew there wasn't going to be anything they could have in common. And please make sure your terms are in descending degree order. Okay, so standard form. So I'm going to go ahead and multiply those two numbers. Okay, so what is 1 times 12? Okay, so 12 is a key number. Okay, and we're going to do this, I call this the lattice. It's just a way of picturing things. Next, I want you to look at your middle term. And you're going to put just the number out in the middle, down at below. So this is what we call the sum number. Okay? So product is red, sum is blue. Now comes the challenge. I got to think of factors of 12 that add to give me negative 8. So you can start with your factors of 12, and you go, well, let's see, 12. 1 times 12, but they add to give me 13. 2 and 6, they add to give me, oh, bingo. Okay, but 2 plus 6 gives me 8. I need it to be negative 8. So what am I going to do?
Change 1 to negative.
If I change 1 to negative, that's going to give me, they're going to subtract because the signs are different. So what? Make both of them negative, right? So if I have a negative 2 and a negative 6, that gives me negative 8. So I have negative 2, negative 6. Okay, you ready for some magic? Okay. Now, notice that the middle term has a variable x. That's the only variable that I want to see in your binomials. We're going to create two binomials. X's will go in front. Remember, we need to get x squared. So x times x is x squared. My two factors that multiply to give me a positive 12, but added to give me a negative 8, were negative 2 and negative 6. And I've just factored a trinomial. So how can we tell if we've done it right? Distribute it out. So if I distribute this, x times x is x squared, x times negative 6 is negative 6x, negative 2 times x is negative 2x, negative 2 times negative 6 is positive 12. Combine up like terms. and I've just verified I've done it correctly. Okay? Let's make it a little harder. I'm going to do a different one, and then we'll do the hardest one. And then we'll go back and practice lots and lots after we write it down. So, again, the game is called product sum. But because it involves positives and negatives, sometimes the sum number is actually a difference. I remember teaching some 6th graders after school one day, and they were dealing with integers for the first time, and I remember one little girl just cried and cried. She goes, I don't get it. I don't get how I'm supposed to add 2 numbers and then have to subtract them. It doesn't make sense. And that's like the first time you saw integers, it's like, what do you mean I subtract? It says plus here. But the signs dictate the math that takes place. All right, so it's still the same game. Product number. What's 1 times negative 15? We get negative 15. And then we take the middle term, sign included, and we get a positive 2. So now I need to come up with 2 numbers that multiply to give me negative 15, but add to give me 2. So this is when you got to start thinking real clearly here. Bryce, what do you think? So he says 5 and negative 3. Let's see. Yep, they do multiply to give me negative 15, and they do add to give me positive 2. So I just write here positive 5, negative 3. So when I do my 2 factors, x is going to be in front because this is what dictates what goes in front. And then I'm going to get a plus 5 and a minus 3. Now, this is the trickiest of them because it's really easy to say, oh, negative 5 and positive 3. That's why you should double check real fast, bless you, to make sure that you did everything correctly. Nope. The binomials, they can be in either order. So x times x is x squared. X times negative 3 is negative 3x. 5 times x is 5x. 5 times negative 3 is negative 15. Let's see, negative 3x and positive 5x, signs are different. Bigger number is positive. I subtract and I get a positive 2x. So that matches, and that says, yep, you've done it right. Okay? So let's do one where the number in front is not 1. So let's do something that looks like this one. 7x squared plus 29x plus 4. Okay? So, and I can use this strategy. I'm going to add an extra step in this one because of the complication of the number not being 1 in front of my quadratic term, and I can use this all the time. What's my product? Positive 28. We always need to get signs. Then we're going to look at the middle term, and we get positive 29. Okay? Now, what are 2 numbers that multiply to give me 28 and add to give me 29? Okay, we get 2 of them, and they're both positive, right? Positive 28, positive 1. For some reason, those are always the factors people forget to think about, the obvious ones, right? But here comes the complication. The complication is that 7. So what we're going to do is go back to what we talked about last week. And what we're going to do is take this trinomial, and we're going to turn it into a 4-term polynomial. How do we do that? Well, we keep the 7x squared, and we keep the plus 4. What we're going to do is we're going to write 29x not as 1 term, but as the combination of 2 terms. What 2 terms? Those 2 terms. So plus 28x plus x. Because before, when we only had x in front, we knew that x times x is x squared. But this one, I have 7x squared. So that means one's going to have a 7, one's going to have an x. How do I know who gets what? And then what happens with all these other numbers? So this is a way to deal with this. So we factor by grouping. These 2 have a 7x in common, leaving behind an x plus 4. And what do these 2 have in common? They have, if you say nothing, then you mean 1. And because the first term is positive, it's a positive 1. And this is the reason why, is we need that match. And we need to have a coefficient so that we can create a new polynomial. So then we get the x plus 4, and then the 7x plus 1 form their own. Okay? So again, we can double check to make sure that we've done it right, and we just FOIL it out, and we get, oops, sorry, don't mean to say FOIL, just distribute. So we get 7x squared, we get plus x, we get plus 28x plus 4, which gives us 7x squared plus 29x plus 4, which matches what we started with. So that says, yep, that's got to be it. Okay? So let's go back to one of those easier ones, oops, and show you how I can use this exact strategy on that. So let's do that x squared, what did we have? X squared plus minus 8x plus 12. So we played our game. We had 12 on the top. We had negative 8 on the bottom. We came up with negative 2 and negative 6. So what we can do is just rewrite this as x squared minus 2x minus 6x plus 12. Patrick.
On the one before that.
Yep.
What is the equation? What does it mean? The one that's above the one that you circled?
This one?
Yeah.
Okay, that's when we're factoring by grouping.
So is that the answer?
No. The answer doesn't, we're not done till we have two binomials.
We still leave the factor because there's two.
Yeah, because we've got, so we still have a common factor of x plus 4. Remember we did that last week?
Oh, yeah.
Yeah. So here they have an x in common, and that gives you x minus 2. Here we have to be cautious, remember? There's a negative here, so we have to pull out a negative and a 6. And that gives me x minus 2. So my answer is x minus 2 times x minus 6. So this strategy with factoring by grouping works for everything. In fact, I think maybe that's what we'll transfer into. And if you feel comfortable when this coefficient is 1, knowing that those are the terms that go into your binomials, that's awesome. Okay? So let's go and let's write down some things. So number 1, we're going to talk about our process. Now, it hasn't shown up, but I'm going to give you one in our examples that does. What's the first thing you always look for when you're asked to factor?
GCMF.
There you go. We're going to look for GCMF. Is there a greatest common factor for all of those terms? If you don't look for it in the front, you have to look for it at the end, and most of us don't even think to look for it then. 2. We're going to play the product sum game. So I'm going to remind you what standard form looks like for quadratics. And that involves A, B's, and C's. Because I'm going to use these coefficients. So it usually looks something like this. Ax squared plus bx plus c equals 0. So standard form is getting ready to solve the equation. Okay? So a, b, and c are numbers of some sort. So the product number is the a times the c. The sum number is the b. Now here's the important thing. You got to watch signs in the product. You got to watch signs in your sum number. The two numbers that make the product sum game work are called our factors. Okay? We're going to rewrite the trinomial as a four-term polynomial splitting the middle term into two terms. And that would be the factors from the product sum game. The whole reason why we play the game. Okay. Now, when I have seen this written, they talk about this idea on the placement test. They call the process splitting the middle term. That's the strategy's name that they call it at the high school. I've never seen it written in our book like that. I've never heard it called splitting the middle term, but that's what the high school refers to it as. So that's why I want to use that language. Then we're going to solve using factoring by grouping. And I'm not going to rewrite how we do that. We took a whole set of notes on factoring by grouping. Okay. Now, we haven't seen it yet, but I have to issue a warning because this can happen. Check each binomial to see if it can be factored further. Okay, so I think that's going to show up on Friday. I'm going to show you that situation. Okay, so if we've looked for GCMF and we've taken it out, we shouldn't have some issues unless a special case shows up. And that special case we'll talk about on Friday. Okay? Yes, sir.
Are we done?
No.
Could you, wait, like, are we done taking notes?
We're going to do some more practice.
Okay.
Yeah. Okay. Now remember, you can always check your answers by multiplying them out and making sure you get what you need. Okay? So let's do some more. Let's just practice with our time that remains. Factor is what it's going to say. So let's do this one. 3x squared minus 17x plus 20. If you know how to figure out these, you can figure out the ones where the quadratic coefficient is 1. Those are the easy ones. These are the more complicated ones. All right, so we're going to play the game. What are the two numbers I multiply? 3 and 20. And what's the product of 3 and 20? 60. Now, it's really important you include signs. What's the sum number? Negative 17. So where this gets a little bit confusing is now I have to come up with factors of 60 that add to give me negative 16, or 17. So here's a couple context clues. Number one, your product is positive. What does that tell you about the two numbers that you would multiply? They both are positive or they're both negative. However, because our sum number is negative, it gives away that we're going to get two negatives. So two factors that multiply to give me 60 that add to give me, Michael. Okay, so we have negative 12 times negative 5. This is where it gets tricky, is now you have to think of your divisibility rules. So what some people do is they just start listing out factors, and they go, well, 1 and 60, no, that gives me 61. 2 and 30, no, that gives me 32. 3 and 20, no, that gives me 23. I'm getting closer. 4 and 15, no, that gives me 19. 5 and 12, finally I get what I need. And you can just list out your factor families, okay? So now what we're going to do is create that polynomial. So it's 3x squared, and then we have minus 12x minus 5x. The reason why I have x is because these two have to add up to equal 17x. And then I have plus 20. So now we factor by grouping. First two have, looks like a 3 and an x in common. That leaves behind an x minus 4. We have a little complication in the next grouping. The middle term is negative, so I must pull out a negative. In addition, there's a 5 I can pull out. And that gives me x minus 4. So together, there's an x minus 4 as the common factor, and then the two coefficients, 3x and minus 5, form their own binomial, and that's your answer. Jackie, do you have a question? Okay. All right, next one. Let's see. 3x squared plus 15x plus 18. All right, what do we need to do first? Nope. Number one thing, GCMF. These all are multiples of 3. So we can start by factoring out the 3. So I want you to see what this looks like. So we have a 3. Now my trinomial looks like this. X squared plus 5x plus 6. So when I play the game, I'm only going to play the game with the remainder polynomial, not with the 3. Where's the 3 going to go? In the front of my answer. Okay? It doesn't get thrown out. So now we're going to play the game with this guy. What's the product number? 6. Positive 6. What's my sum number? Positive 5. Factors of 6 that add to give me 5? Okay, so a positive 2 and a positive 3. Doesn't matter who goes where. So I'm going to show you doing this, factoring by grouping. We still have the 3. Now we're going to split the middle term. Instead of writing it just as one term, we're going to write it as 2. A positive 2x, a positive 3x. Okay, and then we're going to factor by grouping. So the first two here have an x in common. So we still have the 3 out in front. And now we're going to have the x. And then what's left behind is an x plus 2. And then the second group has a positive 3 in common. And when we factor out, we get an x plus 2. So we still have the 3 out in front. Now we have the common binomial of x plus 2. When we factor that out, the two coefficients form their own binomial. And you get this answer, 3 times the quantity x plus 2 times x plus 3. Okay? So again, sometimes the numbers get harder because they get larger and you got to come up with factors. I didn't check, I think most of yours are kind of small, so they're not too bad. Now, here comes the ugly bit. Remember how I told you that the worst thing you can do to a middle school student in particular is to give them answer or questions that don't work out? Well, that's a possibility on tonight's homework. In fact, looking at what you guys have for homework, there are 1, 2, 3 of them are prime. But you're going to have to explain to me why they're prime. Okay, so you got 3 problems on your homework, and I'm not going to tell you which page. They all are consolidated on one page that they're prime. Okay? All right, I will be here today after school if you have questions. And don't forget, you have all those videos attached to the examples in your book for lessons 8, 6, 8, 7.